Regular expressions are commonly used to search formatted string in a larger text. Or you can also search and replace using regular expressions. Here are some examples. There are several functions in MATLAB that help you work with regular expressions. The first one is regexp, and this performs regular expression search. You provide a string which works as a text that you are searching in, a pattern which will be a regular expression pattern that we will cover later, and some options, and we will cover some of those options too. You can, of course, always go to MATLAB help and get some help on how to use regular expression function. Alright, so the first example is where str equals this entire string. And similar to str compare functions, we have a version of regexp that's case insensitive. So this last e, regexp e, makes it case insensitive. So you small at the same time. The way that these regular expressions are constructed are as follows. You have some literal characters, like the C, that will be searched as they appear exactly. So you are searching for a C and a T in the larger string. The brackets specify alternative characters. So this says search for a C followed by any of A, E, I, O, U. Makes it so that you can have one or more of the preceding character. So this would match cat, or cat. Okay. It would also match Kueat. So anything that has a C and a T and one or more vowels will match this pattern. So when you search this pattern in your string, you will get the locations of the matches. So there's a match at the fifth character, where you have the cat. There's a match. This is case insensitive. It will capture both small and uppercase letters. And then you have this chord will not match because you have a C, you have a T, that those are okay, but there's an extra R here which is not specified by this pattern. So this is skipped. And then you have cut, which matches at index number 28. You have CT, which does not match because there are no vowel characters between C and T. And the last one is CAT at character number 35. So you are searching for a complex pattern in your larger text. When I say text, it's also a string, but the larger one I'm going to call text, and the smaller one that you are searching will be called a pattern. Okay? But they are both represented as strings. How do I know where's the ending of a word? This does not know. So if something goes like cats, it will capture this cat part. No. If you have spaces in your pattern, those will be matched exactly also. So if my string contains space, C, AT, then it'll search for a space followed by cat. Alright? So spaces in the pattern are matched exactly in your text when it performs the search. The next example is the same. You are searching for the same pattern, but using the options, additional arguments that you specify as options, you specify, you sort of change the behavior of the regular expression search, or you change what is returned to you from this function. When you provide the string match as an option, then instead of returning the indices, you will get the actual matches to your search pattern. So these are the patterns that matched. These are the substrings from your largest string that matched the pattern that you were searching. Okay? Alright. So in this lecture, I'm going to have a lot of very short exercises, and they will each have bonus points associated with it that you can submit on the course page as we go. Let me show you where that is. If you go to the course page, under general discussion, you can go to the bottom and paste your answers to the exercises that we are going to cover in this lecture. All right. So returning the matches was one way of capturing a portion of your text and extracting those portions only. But in most cases, you would be interested in capturing a portion from your pattern. Okay? So instead of the entire match, you would be more interested in a section of your pattern. And to do that, you would, instead of returning the matches, you would return tokens. Tokens are unclosed parentheses. Okay? And those portions will be returned as a result when you pass the tokens as an option. So what this will do, it will search this text as before, but whenever and the captured elements will be returned as a result, and each captured element will be returned as a cell array. Yes, question. So if you search for C brackets ATAIOU.
Yeah, something like that.
And then T plus T.
But it would like if I had a word like cat,
Yes.
cat and I would put both of those.
That's something I'm not sure about, and we can easily check that. I think it will return only the larger one. Regexp cat CAAT plus T. Let's return the matches. So it only gets the larger one. Okay. So if two matches start at the same location, it would capture the larger one. Okay. All right. So the first, the contents of the first cell is going to be just the character A. Let's actually write this in MATLAB. There you go. Captures. Copy, paste. And then let's look at C1. It contains only A. C2, it contains OA. So what I did by capture, the function only returns the parts that match what's inside the parentheses. Okay, and that's A, U, and then the capital A. Okay. Oh, I'm already listing that here. All right. Okay, so now let's. Those gave you a few examples. Now let's give more details on what else you can do. So there are some special characters within your pattern that you can use. The dot stands for any character. So these are character specifiers instead of writing out all the characters at once, you have these special ways of specifying which characters would match. So that a single dot matches any character. If you enclose several characters in brackets, that matches any of those characters, just like we did when we listed vowels. If you put a bracket, that says do not match any of these. So any character that's not one of those will match. So it's like negating your character sequence. You can use dashes to specify a range of characters. So that will match A, B, and C, or you could do A to Z, for instance. That will match all the characters between A and Z. \S will match any white space. And the white space characters are, I don't know what this \s are. So there are different space characters in addition to the normal blank space that you have. The \S is just negating that. So \S is equivalent to, it's going to be equivalent to saying square bracket, caret, \s. So these two are two different ways of referring to non-space characters. Okay? Alright. \W is any alphanumeric or underscore character. And you can, instead of writing \W, you can also list all of your characters in the square brackets to get the same result. So it'll be small letters A to Z, capital letters A to Z, and underscore, and digits from 0 to 9. All of those are captured in \W. \W is just negation of that. So any non-alphanumeric or underscore will be matched. \D will be any digit. \D is any non-digit. So these are just shorthands that you have. Instead of listing all of your characters, you can use these / things. Alright. Question. If I have here, if I have A space dash Z, no.
A-C space. I guess it doesn't matter.
Oh, A-Z space. So A-Z and then a space and then A-Z. So that will list all of these characters, including the space. So it will also match a space. So this is sort of you can think about it as a vector generating, similar to the colon operator.
So we will only do space, no tabs, no new line.
No, it will only do space. Yes. If you want to capture all of the other white spaces, you have to do \S. Alright, so there are some special characters that you may want to match exactly in your string. Such as if you want to search for a period itself instead of trying to match any character, then you would escape it with a \. So a / period will match a period instead of having this special meaning. Alright, and the / square bracket will match any opening square bracket instead of specifying a character range. Okay? Alright. Next set of examples. So we have this text. The rain in Spain falls mainly on the plain. And we do a regular expression search on this string using .ain. So what that will match is any two characters followed by ain. And to show you guys what it's returning, I'm specifying the match option. So it will match rain. It will match space rain. So there's a space character here which is matched with the period. and then Spain. So S is matched with this with the dot, and then the rest are matched with AIN, and then space main, and then plain. Okay, so all of those are captured with this regular expression. So dots match any character. AIN will have to match exactly. Okay, next example is trying to search for any character RPN followed by AIN. So it will search for the characters RPN followed by AIN, and those will match rain, page, main. Okay? So rain matches it because there's R. You have one out of the set of characters that you're searching, R-A-I-N, R-A-I-N, and then P-A-N-M-I-N. It doesn't, your original text may not contain all of these options, may not contain all of these combinations. If it doesn't, then you will not get a returned result. So, for instance, if you had R-X-A-I-N, this would only match rain. It will not match X-A-I-N because this is not in your string. So it's all, you are only searching within your string for the regular expression pattern. Okay, next example is searching for a capital character, capital letter, followed by \W, which was any alphanumeric or underscore character. So this W stands for words, and basically anything that you can use in a MATLAB variable name. So it's going to be alphanumeric or underscore. And this star means 0 or more. And we will see these special repetition symbols. So this will basically capture all the words that start with a capital letter. Okay? So a capital letter followed by 0 or more other word characters. And those are there and space. Okay? So this one and that one. Okay. So the special repetition characters are listed here in this table. A question mark says 0 or not, 0 or 1. So they are just basically numbers, specifying numbers for how many times the preceding character or character range needs to be repeated. A plus stands for 1 or more. A star stands for 0 or more. And if you need more complicated ways of specifying repetitions, you would use curly brackets. If you use curly brackets and a number, an integer number followed by a comma, that means n or more. If you specify m comma n, that says at least n and at most n. And curly brackets, a single number will match exactly that many repetitions. And so it's important to note that repetition characters only apply to the most preceding character. So this GO question mark, GLE, you are basically searching for a G followed by 1 or 0, all characters, and then it'll match GOGLE, GOGLE or GGLE. So these are the two things that are specified by this pattern. Not all of these combinations may be in your string, but in this case they are. So you are able to search and match this one and that one. If you say GO plus, that says match 1 or more all characters. So what that will do is try to generate the things that we are trying to search. So this pattern will match GOGLE, GOOGLE, GOOOGLE, and so on. Not all of these may be, not all of these would be in your string. The ones that you have will match and will be returned. Okay. Next example is using a star, and that says match 0 or more of the preceding character. So it'll match G followed by 0 number of O's followed by GLE, and then it'll do the rest of it. Okay? So in addition to what you have with a plus sign, you also get this additional one. Alright. If you want more control over how many times a character should be repeated, you can use the curly brackets. This says, I'm searching for a G followed by 2 or more all characters, followed by GLE characters. And that's what we're going to do. Alright? And you can specify the upper, the highest range that you are searching in the repetition. So this example is searching for a G followed by at least 2 and at most 3 all characters, followed by GLE, and this is what we got. Alright, so you can actually rewrite this in terms of using curly brackets. So a star is saying 0 or more. A plus would be curly brackets 1 or more. This one would be curly brackets 0 or 1. Okay? So these question marks, plus, and stars can be written as a curly bracket if you want to, but they're just shorter to write. Alright, here's an exercise for you that you can work on and post your answers on the discussion, and I'll give you a few minutes to do that. Let's construct our string first. I just copied and pasted that string into MATLAB so I can work with it here. Let's first capture the or the str. If I just say the, let me just return the matches. I'm capturing the two the that occur, but I want the to be repeated once or twice. Okay? So I'll capture the or the. And then followed by a space. They'll capture the space also. Okay? And then followed by a word. A word will be \W. That's a single character, and I want more of them. Okay? Or you could say small case letters, uppercase letters, underscore, or numbers. And then you want 1 or more of them. Okay? So that matches the second, the fourth. Now, the question is asking you to capture the words that follow the or the. So to only capture the word but not the or the, you would enclose the part that you are interested in with parentheses. And then you would replace the match with tokens because you are no longer interested in the entire match. You are interested in the captured tokens. And ans1 will contain second. ans2 will no longer contain second. So let me just say A equals that. A1 second, A2 is fourth. Next question is asking us to extract the last word of the sentences. Okay, so to figure out the last word of the sentence, I need to search for a period. Sorry. Let's search for a period. I'm just going to change this expression. Let me return the matches, which is easier to follow. To specify a period, I would have to do \dot. Otherwise, if I do dot, it'll match every single character. \dot will replace only periods in the string. There are 4 periods. Okay. including the periods that occur in the numbers. I want the period to come after a word letter. And as a word is defined as it should have at least one letter. So it should have at least one A to Z or capital A to Z, and then 0 or more other word characters. Okay, so that's item and fourth. Alright, so I captured the last word in each sentence. Did you guys follow this example? Should I go over it again? Alright, go over it again? Okay. So let me walk backwards again. So what I did, I first matched at dot. What that will do, it will match with every dot in the sentence. That guy and this guy and that guy. And I'm returning the matches, so you don't really see where the matches are, but if you want the location of these things, you can just do that. They'll give the locations of the matches that it finds. This will be the matches itself, the matches themselves. Now let's do dot dot dot. They'll capture the previous three letters also, followed by any 3 letters followed by a period, any 4 letters followed by a period, and so on. Okay? Now, within these candidates, I want only those that are words, meaning they should contain at least one letter. Like this one should not match. This 13 dots should not match. Okay? To specify that I am looking for a letter, I would say A to Z, A to capital Z. That'll match anything that ends with a letter, followed by a dot. But before or after this, I am allowing numbers. And I can either say A to Z, capital A to Z, underscore 0 to 9, star, or I can just say \W star, which is the same thing. And before that letter, I also want to capture other characters that are word characters. Okay, so they'll match item, period, and then fourth period. Next question is asking us to extract all numbers. To extract all numbers, I can either say 0 to 9. If let's just capture them one by one. So that will capture each digit. If I do 0, 9 plus, they'll capture all numbers such as 10, 13 are captured together. If I am searching for floating point numbers, I can do 0 to 9. Well, before I do that, let me just replace the 0 to 9 with \D, which stands for any digit. Okay, so I'll get the same result. It's just a shorthand for saying any digit. If I want to be able to specify floating point numbers, I would do \D plus and then a period and then another \D plus. Okay, they'll capture all the floating point numbers. Now you may want to make the dots optional. I mean the floating points optional. So you would to do that, you would enclose it in parentheses and then put a question mark after that. So that says match any number of digits and then match 0 or more of whatever's inside this parentheses. So it'll match \D plus a digit, one or more digits followed by a period followed by one or more digits. It will also match a digit, one or more digits followed by nothing, because the question mark is generating 0 or more of the preceding expression. In this case, the preceding expression is a dot followed by numbers. So if I do this, I'm capturing 1, 2, 3, 4, and then 10.5, 13.5. Okay? Question?
Did you change that example to token? You would only get the decimal?
Yes, I will only get the decimal. That's correct.
And isn't the question mark 0 and 4 1? You said 0 and
Say it again.
You said the decimal was 0 or 1.
0 or 1. Yes. So you are only getting the decimals, but there's a trick. There's actually this will match when a number is not followed by a decimal, and also the numbers that are followed by a decimal. So for some of the things that you capture, the decimal will be empty. That's why. No. So here, that expression will capture this 1. So the whole expression is captured, but your token is empty, because inside the parentheses it's not matched against anything. Does that make sense? That's why when I did A equals that, and then I looked at what's inside A1, it's just an empty string. A2, also an empty. A3, empty. A4, A5. Some of them should not be empty. There you go, 0.5. Okay. If you want to enforce that there should be a decimal, then you would do a plus. Okay? So that means I want at least one decimal point. Yeah, this is trickier than the constructing is a little bit trickier than you would want. So if you really want to do this, so if you do, okay, let's go back a little bit. If you do period and then a digit, and then you are replicating that, okay, what that means is it'll be 1. So you are trying to match up against 1.2.3.4.5. So dot number is being replicated. What you really want to do is you want to replicate just the number part. So that's why you need to take this out of the parentheses. And since you have a single character, you no longer need the parentheses. So this will only match numbers with a decimal point, which there are none in this case, which is weird. Oh yes, you're right. So if I do match, I'm going to do this. Okay. All right. You can group things. In this case, so grouping means you are using the parentheses. And non-capture you are just using the parentheses to help you group characters together, but you're not interested in returning them as a token. Alright, similar in text scan, this is similar to saying %star when we were looking at the text scan function. So you are matching against your string, but you are not really interested in returning them. You're returning what is matched. So as match, but don't return. You may need to enclose your expressions with these non-capture grouping, for instance, to repeat them, because repetition only works on the preceding expression. If you want to, for instance, replicate AB to match AB, 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 this would be the way that you would express it in regular expression. If you don't put parentheses and say AB plus, then it will only generate AB, ABB, ABB. Okay? So you are using parentheses to group things together so that when you repeat them, they will be repeated as a chunk. Alright, so let's do this example. Marge lets Nora seashells telegram. and we are matching, what we are searching is any character that is not a vowel. So this term negates what's inside. So basically what not so consonants or other characters such as spaces. So any character that's not A, E, I, O, U, followed by a vowel, a single vowel. Well, and then we do two or more of them. So we are doing a non-vowel followed by two or more vowels. And that will only match C. So you have a non-vowel followed by at least two vowels. Alright? Next example is searching for a non-vowel character followed by two or more vowels. And I'm missing. Oh, alright. No, there's a parenthesis here. I didn't realize that the parenthesis was ending there. So let me repeat this from the beginning. So what I'm doing, I'm searching for a non-vowel followed by a vowel, and this whole thing repeated two or more times. So a consonant, a vowel, as a block, repeated two or more times. And that will match a consonant, a vowel, that's my block, repeated twice, a consonant, a vowel. Alright? So you want to repeat this entire pattern twice instead of just the vowel itself. So that's going to give you a different behavior. Where we just repeated the vowel itself, you got consonant, vowel, vowel. When we repeated this entire thing, we are repeating consonant, vowel as a single block. So you get consonant, vowel, consonant, vowel. Make sense? Alright. Some of these are sort of advanced features, but I just want to make sure that you guys are familiar with what's available, because you might end up needing them. It's easier if you know that they exist. You can still go and learn about it, but if you don't know that such a thing exists, it's harder to know that you can do it with regular expressions when you don't know the power of regular expressions. Okay, look ahead is another way of grouping. It's a non-capture grouping, which means you are not capturing as part of your expression, as part of your match. And let me go back. So it's very similar to this non-capture grouping, and it's you would usually use it on the left-hand side or the right-hand side of your expression. So what you are interested in is, in the first example, which does not have look around, you are interested in tele followed by 0 or more word characters. So you'll match tele, you'll match tele-x, you'll match tele_, you'll match tele-eee. So any tele followed by any word characters. Okay, so those are the things that it will match against. And as a result, if you match from your sentence, from the string which contains telegraph, television, telephone, you'll get all of the words. The second example says look behind. So this look behind is question mark smaller than equal. That says look behind. It should have a tele, but I'm not interested in that portion that's matching. So this will go through your string, find the things that match tele followed by word characters, but when you are returning the matches, it'll ignore the tele part. Okay? So you have an expression in mind that has some constraints on both ends. So you want to look behind or look ahead, and the look behinds and look aheads will also be matched as your constraint, but they will not be returned as part of the match. Another way of accomplishing the same job would be to just not worry about them, and then put what you are interested in parentheses, and then instead of matches, you can return tokens. So they'll get the same effect. Okay. If you want negative look ahead or look behind, you would replace the equal sign with an exclamation mark. For instance, that would say, let's get an example. Question mark. Let me get this. Yeah. Question mark. Exclamation point. And if I still look behind, it's easier. Question mark, smaller than sign, exclamation point, tele, and then a word, star. So what this would do, it will match any word characters that are not following tele. So you are basically negating your look behind. So you're only looking for words that don't have this tele prefix. Okay? Alright. When you have brackets, you are giving alternative characters to match in your expression. But sometimes you may want to provide alternative words to match in your expression. To accomplish that, you would use this pipe symbol. Okay, so this will say search for a digit followed by a space, and there's a new line, there's a hidden new line here since the whole thing did not fit in one line. And a digit, one or more digits followed by kilometer, kilometers, or km. So it will match against all of those different alternatives. So if my string is 10 kilometers and period 1 kilometer, and I'm searching for this expression, it will capture digit followed by space and this kilometer, because those are the alternatives that are matched. And then also this one. Okay. The next example is searching in black velvet. You are searching BL characters followed by either ACK or UE. So you are effectively searching whether your string contains black or blue. Alright? So if there were a blue velvet or blue something in your string, it would also capture the blue part. Alright, another exercise. Given in that string, extract all of the black or gray animals that they have at the zoo. So the sentence is they have a black cat, a gray elephant, a yellow snake, a brown pigeon, a gray wolf, and a white bear at the zoo. And you are asked to extract only the black or gray animals. It should be simple. Give me the previous slide. So let me, I might have forgotten to mention where you would use regular expressions. So when you're working with your files and you are trying to parse them, using sprintfs, using scanf or textscan may not be possible, may not be the easiest way to parse your strings, and they may not be very flexible. If you use regular expressions, you have more power over what you can match in your text files or in your other strings that you are parsing. Okay. So if you can construct a regular, for instance, when people enter data, they may have different ways of entering data. Some may enter commas, some may encode, some may separate numbers with spaces, some may separate numbers with tabs. And you may be dealing with, when you're in your project, for instance, you may be dealing with files that are created using different conventions. They still have some commonality, but they have portions that are different, okay? And to be able to parse those files, you need to construct a regular expression that captures those conventional parts and provides flexibility for things that are different. Make sense? Okay.
So you need to read them to string first?
Yes, you would need to read them into a string first.
So you use
You can use fget line if you want to parse line by line, or you can read the entire thing into a single file first. So you can copy and okay. For those of you who missed the explanation, the solutions are on the web in the discussion. So the positional operators will sort of limit where you are trying to search in your string. If you start your expression with a cat at the beginning, that says only search from the very beginning of your string. All right. So if you remember the PDB file that we were trying to parse, where we were reading each line and we were testing whether the beginning of the line contained atom. So one way of doing it using regular expression would be to match each string using this expression. So we would do caret sign atom, that will check whether the string starts with the atom. Okay. So the caret says I want the match to start at the beginning. The dollar symbol at the end says that the pattern should end at the end of the string. A backslash format sign says there's a word boundary there. So that would be the beginning of a word. It doesn't really match against any characters, so it will not capture it will not capture the space, but it will stress that boundary for the word. So if you have a backslash smaller than cat, that will match space cat, but it will not match, let's say, xcat. It will not get the xcat part because in the xcat, there's no word boundary before the cat that you are searching. Okay, so this backslash smaller than and backslash greater than are how you would search for word boundaries. And they are explained also in this table. You can back reference previous tokens. So using these parentheses, I have captured a word. So that says capture the word that has one or more word characters. And then an equal sign. And then backslash 1 says I want the first captured element to appear exactly in that location. Alright, so it'll go through your string, find a match for this backslash W plus, so that it will be any word. So it'll be one, it'll be this part, that part, that part, that part, that part, that part, that part, followed by an equal sign. So it'll match up with the equal sign. So these other ones are eliminated. So they are no longer part of the match. So this one is a candidate. 1 equals, 1 equals, 2 equals, 2 equals. And then you do backslash 1. It says I want the captured element repeat here again. So you'll only do 1 equals 1. This one is good. The first captured is returned. 2 equals 2, that's okay also. Okay? So you are back referencing previously captured tokens in your string. And as a result, you get 1 equals 1, 2 equals 2. Okay? So this expression is searching for anything equals the same anything. So these two will be equal. Another function in the regular expression functions in MATLAB is when you want to replace a substring with a new string, and that's regexp rep. This last RAP stands for replacement. So you want to do regular expression replacement. And the way that it works is you have a regular expression pattern, just like you had for the regexp function, but in addition to that, you would have a replacement pattern. So you want to find the instances for this pattern and replace them with this other expression. So what this will do is it will search for a capital letter followed by small case, one or more small case letters, followed by a space, followed by another capital letter, followed by small case letters. And what it will do is it will replace the match with this new string. And that new string contains references to what you have captured. And those are specified with the $sign. It says take the second captured element, place it in here. So the second captured element will be placed here, followed by a comma, space. Take the first captured element and place it after that. Okay? So as a result, what you are doing, you are capturing a capital letter followed by a small case letter, followed by a space, and capital letter followed by small case letter. So it will match John Smith. And then you are replacing it with Smith, comma, John. And then you are doing that for all occurrences of this expression. Okay? So you are effectively switching first name and last name that you see, or any two words that you see in the sentence. Any questions? So let's do this one in MATLAB. Okay. Now let's see. I want to do this all in one line. So anything in the replacement string will be placed as is. Okay. So this will be put exactly when it's replacing the string. If you don't have the $1, then you are sort of ignoring the first captured element. If you don't take the $2, then you are ignoring that too. So what this would do, for instance, it would just do XXX, YYY for each match, if you want to get rid of all the names in your sentence. Okay? Alright, so the replacement string can be anything. If it has a number, that refers to whatever has been captured by the regular expression, the tokens in your regular expression. Okay? Any questions? There's something called named capturing. So in named capturing, you don't really want to keep track of numbers. You don't want to just say do the first match and the second match and so on. You want to give names to what you have captured. So you want to give names to what you are capturing in the parentheses. And the way to do that would be a question mark and then enclose in smaller than sign and the greater than sign the name that you want to give to that captured element. So this it'll exactly do the same thing, but you will be able to refer to the captured elements using their names. Okay, so I'm capturing a capital letter followed by one or more lowercase letters, and I'm giving them the first name. And then a space character, same thing, but now I'm giving it the last name. In my replacement, now I can use the names that I used in my capture. It allows you to semantically refer to the things that you captured instead of using numbers. You can do the same thing when you are using regular expression match, so the regexp function. This example is basically the same as the one before. Here you go, name tokens. So same logic, but now instead of the regex replacement function, I'm using the regex function. And for each of the things that I'm capturing, I'm giving them names. So let's say you have a large text that contains a lot of addresses that are more or less in the same format. In the same format, meaning there's a number followed by a street name or a road name, followed by the word street, road, avenue, and so on, followed by a comma, the city name, comma, state, comma, zip code. And you want to parse your entire file, your entire string, and capture all of those, all of that information in a single regular expression. And you would use this regular expression to do that. So you would do, I want a number, followed by a space, followed by one or more non-space characters. So number followed by a space, followed by one or more non-space characters, followed by a space, followed by the word road, street, avenue, or drive, which will capture that part, followed by a comma, followed by a space, followed by a capital character and small case characters, which will match the city, and you are giving it the name city, so it will be returned as the city. Since the state as a two capital characters, comma, and then the zip code as 5 digits. And as an option to the regexp function, you are providing names instead of what we did before. We did tokens before, but now you want to get a named structure. So as a result, you will get a structure with these contents in it. And if your string contains not just one address but multiple addresses, they will all be returned as multiple structures. So let's try this. And let's change S to contain 3120 Market Street, Philadelphia, Pennsylvania 19104. And let's repeat this regular expression. Now you should be getting just set it to ends. So A1 will be the first one, the first match, A2 will be the second match. Okay? Alright. Dynamic regular expressions are where you want to run a MATLAB code in the replacement regular expression. So these are used in when you are replacing a portion of your text with a new string, but in the new string you want to use a MATLAB code, so that's why it's called dynamic. It's not something static that you're not placing static letters, static characters. It's going to be computed on the fly using the functions that you provide. So in this case, what I'm doing is append all words with their lengths. So it will capture all the words in the sentence. This is what it does. I'm capturing one or more word characters. Basically, I'm capturing all the words in the sentence. And $1 will be the first captured group. So it'll be itself, followed by a colon sign, followed by dollar curly bracket and a special meaning. It says execute what's inside as a MATLAB code. So it will do num to str, which converts strings to numbers, and then the length of $1. So it'll take the word that you have captured, find its length, convert the length, which is a number, to a string, and put it after the colon sign. So as a result, you get GGLE:4, which is the result of this expression. So it's the result of num to str, parenthesis, GGLE. Sorry, yeah, GGLE. So it computes this on the fly and places that for that. So the dynamic expression should evaluate to a string to be able to use it in the regular expression replacement. This is very powerful. There are a lot of neat things you can do with it. it may be a little bit tricky to figure out what's going in and what's coming out. All right, another example is we want to randomize all but first and last letters of each word. So let's examine the regular expression pattern first. I am matching a word character using look behind. So what this will do, it will look for a word character but not capture it in the match. And then I also have a look ahead that also matches a word character. So it'll be matched, but it will not be returned as part of the match. And then \W, I want 2 or more word characters. Okay, so this will match all. This entire regular expression will match all 4-letter words, the words that have at least 4 letters, ignoring the first and the last character. Okay? And then what I do with it is $0 stands for the entire match. So $1 is the first token that you are capturing. $0 is the entire match. So no parentheses needed. So when I remember, I could either do match as the option or tokens as the option. When I did tokens, it would only return me the ones that I have in the parentheses, starting from $1, $2, and so on. When I do a match, it matches the entire string, ignoring the look ahead and look behind, and that's referred as $0 when you are doing a replacement. Okay. All right. So what I'm doing is $0 is the string itself, which is the second all the way to the 1 before the last character in your word, and then you are randomly permuting it. So this creates an index using the length of the string, and you are basically randomizing your string. So let's try this in MATLAB. Let's say S equals ABCD. If I do S, random permutation length of S, that will randomize my string. So random permutation generates a random set of numbers that go from 1 to the number that you provide. And you can use that as an index to your string to shuffle your letters. So instead of S, I have $0. All right, let's try this exercise in MATLAB. One flew over the cuckoo's nest. There you go. And as a result, you get this. Each time it's randomized slightly differently. Since the word is not too long, you may get the same result after several tries. So there's actually a psychological phenomena that if you have a text where you keep the first and last letter as they are and shuffle around the other characters, you would still be able to read it. Okay? And we wrote a neat MATLAB regular expression to perform that change. All right, any questions? Okay. Last example, which is an exercise before we take a break, is Caesar cipher that is generated by replacing each letter with the next letter in the alphabet. And you are asked to write a regular expression replacement function to decipher it. So what I want to get as a result is T H E S Q. What comes before V? Can you guys decipher in your head? I could do it, but we want a regular expression to do it. Okay. Let's do it in MATLAB and see the result, and then we'll do it in so the quick brown fox jumps over the dot. The problem with -1 is the space characters are sort of ignored. They're not ignored, but you cannot really see the result because I don't know what. So space character is 32. If you do character 31, it's a non-printable character. So that's why you don't see it. So you want a regular expression that will only subtract 1 from word characters. Oh, they're still there on that computer? Okay. Yeah. Okay. But it's not correct. I mean, the underlying binary data is not a space. If you tried, for instance, so this would be, let's say t equals that. T3 is going to be an E letter. T4 is going to be a non-printable character. If you say T4 equals a space, you'll get a false. So there's a hidden character there that is not printed because MATLAB doesn't know how to print. Okay. All right. So let's give you a few minutes to think about this while I take my break. So let's copy and paste this. First, let's copy the sentence. What sentence is there? Okay. So what's done here is your regular expression contains \w plus, which says capture, which says match 1 or more word characters, and the word character is a small case letter, an uppercase letter, underscore, or digits. Okay. So this sentence doesn't contain any underscores or digits, so you are safe by using \w. And then in the next part, you are specifying what you would want to replace whatever you matched by. So you are searching your string, and then for those portions that matched your search pattern, you want to replace them with something else. And that something else is generated by a dynamic expression. And the dynamic expression starts with a $sign and a curly bracket, and what's inside will be interpreted as a MATLAB expression. Any $zeros will be replaced with the entire match. Any $ones will be replaced with the first captured group. Since there are no captured groups in your pattern, a captured group meaning a parenthesized expression, then there is no $1 in this example. Okay? So if you enclosed it in parentheses, then you could use $0 or $1 since you are capturing the entire match. Okay, so let's go back a little bit. Alright, so this works. Other things that would work is if you just captured them character by character, you would still get the same result. Let's say we wanted to do this operation only on the first character of each word. Then you can change your regular expression pattern to contain a word boundary before the W. So that would, for instance, match only the first letter of each word. Okay, so you are performing the regular expression replacement on whatever you matched, which is just the first characters of each word. There was a question. So the 0 and 1 will give you the same answer, because if I do a capture using parentheses, in my regular expression, $0 refers to the entire thing in the quotes minus any look aheads and look behinds. $1 would be the first captured group, so the first parenthesized expression. Since the parenthesized expression is the entire string for this example, then it would give the same result. So $1 and $0 would give you the same result for this specific example. When they would not give you, here, let me show you the how they would differ. So let's try to do let's try to match a word boundary followed by the first letter followed by other letters in the word. Let me just let's capitalize them, upper, which is going to be easier to see. So what that will do is your match, your regular expression matches the entire word, but your $1 is only a portion of it. That's why you lose the first letter, because you take the entire word, replace it with only the $1 portion. You are ignoring this first portion. Does that make sense? If you did $0, then that would be the entire thing that matches. So it would be TIFF, QV, JDL, and so on. Okay. There you go. Then you are uppercasing everything. So for instance, if I had a string that contained this and other things, and I want to make it so that only the first character of each word is capitalized, then what I would do is the following. I would do a word boundary, and then a word character followed by one or more word characters, and then another word boundary, the end of the word boundary. And then I would do upper of the first captured element, and then lower second captured element, and I need to concatenate them. Okay? Makes sense? Alright. Any other questions? So this concludes the regular expression topic.